So what other type of circuits, diode circuits can we think of?
Now, see, we have Vm across the capacitor. Can I get more than that?
Okay. I see. So the voltage across the capacitor is Vm. You want to get even more.
Yeah.
Okay.
Because I see after shifting across the diode, you have 2 Vm.
That is true.
So can we charge?
You want to use that to?
Yeah. Can we use another capacitor charge to that 2 Vm?
Let's see. Let's see. Okay. So then let's see if we can do that. Okay.
Yeah.
I'll try to redraw the circuit differently.
Yeah.
So maybe we had a diode here.
Yeah. So we can maybe keep it some angle.
Maybe I'll keep it at some angle.
Because definitely we need
some space, no?
Yes.
Because we will probably want to use this voltage across
to charge another
one. Okay. I'll draw it like this. So this is some D1. This is C1.
Yeah.
And this is still Vm sin omega t.
Yes.
Okay. And we know that this voltage, so I'll show it like this, is Vm plus Vm sin omega t.
Yeah.
I mean, I'm not showing the polarities here, I'm just showing that it is
correct.
It is
so
like that.
We have 2 Vm at some instant there.
At some instant. It is happening at this instant.
Correct.
Correct? Okay. Well, the capacitor charged to plus minus Vm. So you are suggesting putting another diode plus capacitor?
Yeah.
To see if we can charge it to 2 Vm.
Yeah.
Let's try it out. Let's try it out. Okay. So let me take this portion of the circuit. Okay. And you want to connect one more. Huh?
Yeah.
Which way shall I? Now, which way should I connect?
So we'll mark the direction for the capacitor charge.
This
is
Vm.
plus minus.
Correct.
So the another set of diode and capacitor should charge from this capacitor.
Should charge from this capacitor.
This capacitor plus Vm sin omega.
So I need to draw the diode such that the current can flow downwards.
Correct.
Right? I understand now. Okay. So I'll show it like this. Like this?
Yeah.
Okay.
And then we'll
put a capacitor here?
Yeah.
Okay. So now this was plus minus Vm.
Yeah.
So this is Vm plus Vm sin omega t.
Correct.
During the peak of the first cycle,
so
Vm plus Vm sin omega t looks like this.
Yeah.
So something like this.
Correct.
And during this portion, this capacitor, I'll call it C2.
Yeah.
When the diode is forward biased,
it will charge
at this portion in the positive half cycle, then it will charge to 2 Vm. In this direction, is this correct?
Correct.
Oh, perfect.
So we have
this is a voltage doubler.
Voltage doubler.
Nice. Okay.
Yeah.
So, correct, perfect. So I actually get twice the peak, right? 2 times the peak voltage.
Yeah. We don't have the sine wave.
Yeah, not across the capacitor.
Doubling the sine wave, but
we are not correct. We are getting twice the peak of the sine wave.
Yes.
Okay. Yeah. So that's what I started writing. 2x the peak of the sine wave.
Yes.
Oh, perfect. Okay. Oh, this is a very nice circuit.
Yeah.
Can I keep doing this?
You can, I think.
You can.
Yeah.
Oh, nice. So it is not just. So this is a doubler.
Yeah.
Right. So what you are saying is that this you can keep doing.
You can keep doing
naturally
because across the D2 we have more voltage now.
We
that can be
now. Naturally, because I can see that if this is 2 Vm, this is Vm, most likely you will get a copy of the sinusoid plus this voltage shift.
Correct.
You can keep doing this maybe.
Correct.
Until probably there will be some point where the diode might break down, no? Reverse bias.
Yes.
Or the capacitor can also break down.
Yes.
Right?
Yes.
So one of these two things will happen. Nice. Okay.
Also, if you are connecting some load, then this capacitor will discharge.
That is true. That is true.
So again, it will get charged in the next cycle and so on. But it will be somewhat close to 2 Vm.
2 Vm. Perfect. Okay.
But usually these are for, not to power some load. It is to shift your signal.
Shift your signal. That is correct. So we are not trying to deliver power to something.
Correct.
Right? Correct. In fact, broadly, You can think of two uses of electrical and electronic circuits, no?
Yeah.
One of them is to power.
Correct.
The other is to transfer information or
Exactly.
operate on signals,
Exactly.
no?
Exactly.
Correct. So I understand what you're saying. Okay. And this can also be a multiplier,
Yeah.
right?
Yeah.
To a voltage multiplier, right? Nice, nice.
Now, if our AC source, if that is DC,
Oh, okay.
will
Let's try that
it
out.
work?
I wonder. Let's try it out. I like this. We had this. Shall we use the same polarity?
Yeah, yeah.
Why not? So you want some VDC, no?
Yeah.
So I'll call it VDC. This is some capacitor, and we'll put the diode like this.
We can put like that.
Correct. But if I put the diode like
It's
this,
always reverse
it is
bias.
always reverse bias. Nothing will happen.
Yeah.
So let's try the other way.
Hmm.
Hmm?
Yeah.
Like this.
Hmm.
Okay.
So diode will charge to VDC.
No, capacitor will charge.
Sorry,
to VDC.
capacitor will charge
Correct.
to VDC.
So diode will be forward biased.
Correct.
So current will start flowing
Yeah.
till the capacitor charges to VDC,
Yeah.
right? Oh, but the minute it charges to VDC,
Hmm.
the diode will go to zero bias.
Yeah.
And after that, nothing happens, no?
So across the diode, we will always have 0 volt.
You will have zero for ideal diode. Otherwise, you'll have 0.7.
Hmm.
The capacitor will charge to plus or minus 0.7, something like that. It will
Correct.
stop,
Correct. Correct.
right? So
So it's not going to double.
Correct,
I mean,
it's
even
not
if I
going to
add one more set of diodes and capacitors, it's not going
nothing is going to happen. So doesn't work for DC, no?
Hmm.
Okay, okay.
Otherwise, we have to charge the capacitor and then there should be a way to flip the capacitor.
That is true. Maybe if you want to flip it, see, last term in electronic systems thinking and circuits, we looked at sampling voltages across a capacitor.
Okay, okay.
So maybe like switches and capacitors, if you have them, maybe you can do that.
Then we can.
Because you can flip the polarity, no?
Yeah.
Periodically. So maybe, yeah, maybe they'll learn about it in future courses.
Yes.
Right?
Yes.
So
Yes.